Okay, so let's look at number 6, calculate the enthalpy of atomization of copper. So we are going to make copper oxide, so we must be making copper oxide from copper and oxygen, enthalpy of formation, so we would be using the elements. So let's have a look at that. So we've got copper as a solid, and oxygen in its standard state is a gas, and we're going to be making copper oxide, CuO, and that's a solid, and actually we only need half a mole of oxygen. Oops, there we go, you can see that. Okay, so that's the enthalpy of formation. Let's go here. So we're going to atomize the copper. So there's copper as a gas. We are going to take an electron off copper. So copper plus as a gas, and there's the electron. We're going to take a second electron off copper. And there's one electron there already, so that would give me 2 electrons. And I haven't done anything with the oxygen yet, so I'm just going to transfer it up here, showing it hasn't changed at all. Plus a half O2, plus a half O2. Oops, let's put the gas in and the gas in. Alright, so the next thing I'm going to do is I'm going to atomize the oxygen. So I'm going to break that oxygen-oxygen bond, and I'm going to get 1 oxygen atom, 1 mole of oxygen atoms. Here I've got half a mole of oxygen molecules. I'm going to get 1 mole of oxygen atoms. Right, let me just put these up here. Cu2 plus gas plus 2 electrons. Okay, so the next thing that's going to happen is this oxygen is going to pick up these electrons. So the first ionization of oxygen, let's go here. So this is the first ionization of oxygen. O minus as a gas. So I've still got Cu2 plus as a gas, and I've still got, I'm going to have to put it here, and I've still got an electron. Okay, so the next thing that's going to happen is this oxygen is going to pick up another electron. So it's going to pick up a second electron. So here it is, it's picking up its second electron. So this is O2 minus as a gas, and there's our copper 2 plus as a gas. And then those ions, those gaseous ions, are going to combine together to give us copper solid. Right, let's put some values on these now. So we've done the cycle. Let's see what we've got in our paper. So we've been given the enthalpy of formation as minus 155, and we've been given the lattice formation enthalpy as minus 4149. So let's put that on. Minus, oops, let's do it again. Minus 4149. And minus 155, minus 155. Okay, let's put everything else on now. So what was the atomization for copper? Was that what it was asking us to do? Yes, it was. So let's put an X on there. Here we've got the first ionization enthalpy of copper. So first ionization enthalpy plus 745, plus 745. Second ionization enthalpy plus 1960, plus 1960. Now what else did we do? We atomized the oxygen. So there's oxygen, and there's the enthalpy of atomization. So plus 248, plus 248. It was only for 1 mole, so that's okay. The next thing we did was we had the electron affinity of oxygen, and that would be here, first electron affinity, minus 142, so minus 142, minus 142. Oops, you can't see that. And then here we have the second electron affinity, and the second electron affinity for oxygen. Oh, it's not on there. Is that what we're trying to... Oh no, let's look down here. Here we go. Plus 844. So plus 844. Right, let's go around this cycle then. So I want to find out what X is. So if I start here and go to there, that would be the value for X. So X equals... Now, the way I'm going to go around the cycle is I'm going to start here, and so that's going in one way. I'm going to go in the opposite direction. So I'm going to go in this direction. So that's minus, I'm going with the arrow and the sign, so it's minus 155. I'm going against this arrow now, so I'm going to flip this sign. So that's plus 4149. That's up here. I'm then going down here, so I'm going against that arrow, so that's not that's minus 844. Coming across here, I'm going up this way, so I'm again going against that arrow, so I'm going to flip the sign, so that's plus 142. Down here, I'm going against this arrow here. So I've come here, I'm going against this arrow, so that's minus 248, minus 248. I've come that way, go across there. I'm going against this arrow, so that's minus 1960. I'm going against this arrow, which is minus 745, and I finish at the same point. Okay, so I finish here. So X equals all of that. So X equals minus 155 plus 4149. I will add them up and I will give you that value. Okay, so when we add all of those black numbers up, that comes to plus 339. So what that's telling me is the enthalpy for atomization of copper is plus 339. And we know that in order to atomize copper, we're going to have to put some energy in. So being positive is a good indicator that we've got it right.